Right, okay, so we have two vectors here. So we've got vectors u equals 8i plus 2j minus k, and v, which is minus 3i plus tj minus 6k, and we've been told they're perpendicular, and we've been asked to find the value of t. So this is quite a nice one to start us off. So we know if perpendicular, then the scalar product is 0. So therefore, our scalar product u dot v is going to be, so we take the coefficients of our parts of I, so 8 times minus 3, and then we add, and so now we're looking at the j component, so it's 2 times t, and then we're going to add our last bit, which is our k components, or z kind of components. So we have minus 1 times minus 6. So going from there, so we know we're going to have 0 is equal to 8 times minus 3, which is minus 28, 16, 24, plus 2t, and then plus 6. So if we sort all that out together on that hand side of the equation, on the right hand side, minus 24 add 6 is minus 18 plus 2t. So we have 0 equals minus 18 plus 2t, so we add 18 to both sides, we get 18 is equal to 2t, so t is equal to 9. So that's question 1 done. Nice and easy start there. Right, so for question 2, we've been asked to find the equation of the tangent to the curve y is equal to 2x cubed plus 3, where x is equal to minus 2. So, we know that m is equal to dy by dx for tangent. Okay, so we need to differentiate. So we're going to have dy by dx, and to differentiate we multiply through by the power. So that means 2 times 3, so we get 6, and then we have x, and then we subtract 1 from the power, giving us 2, and our number disappears. So then at x equals minus 2, we have dy by dx is equal to 6 times minus 2 squared, which is 6 times 4, so we have 24. Okay, so we also need to find the y value at that point. So we have 2 times minus 2 cubed plus 3. So we have 2 times minus 2 cubed is going to be minus 8 plus 3. So that would be minus 16, add 3, so we get minus 13. So we have the point minus 2, minus 13, and we know that m is 24. So we have y minus b equals mx minus a. So we can substitute that in, that's our a and our b there. So we're going to have y plus 13 is equal to 24x plus 2. We need to multiply this out and sort everything out, so rearrange it all. So we're going to have y plus 13 is equal to 24x plus 48. So then we set it so we have y equals, so we're going to subtract 13 from both sides. So 24x plus 35 when we subtract 13 from our 48. Okay, so that's us for question 2. Okay, so question 3, we've been asked to show that x plus 3 is a factor of x cubed minus 3x squared minus 10x plus 24, and to hence factorize fully. So, first things first, we are going to use synthetic division. If this isn't the method you've used, then you can, I have some videos on how to do this by long division if that's the way you've been taught to check it, or if you want to learn the synthetic division, there's videos on that as well, in the topic of Unit 2, so expressions and, relationships. Yep, relationships. Right, so we've got our coefficient over x cubed is 1, so that's why that's a 1 there. Our coefficient over x squared is minus 3, so that's why the minus 3 is there. Coefficient of the x is minus 10, and the coefficient of the constant is 24. So we've got those there, and with x plus 3 as a factor, we have minus 3 with our synthetic division. So we pull down our 1, we times our 1 by our minus 3, so we get minus 3. We add these together, so we're going to get minus 6. Multiply those together, so we get 18. Add those together, giving us 8. Multiply them together, so minus 3 times 8, giving us minus 24. Add those two together, so we get 0. So, therefore, as the remainder is 0, that means it is a factor. X plus 3 is a factor. Okay, so now we can factorize fully. So we have x cubed minus 3x squared minus 10x plus 24. That's what we started with, and it's equal to, so we have our x plus 3. And then this bit in here gives us our coefficients of our quotient, or what's left when we divide. So we have x squared minus 6x plus 8. Okay, so then we need to factorize further. So x squared is going to be x and x. So we've got plus 8, but we've got minus 6. So if we have a plus in our last term and a minus in the middle, it means they're both going to be negative. And what multiples of 8 add to give us 6? Well, that has to be 4 and 2. And that's us for question 3. Okay, so we're on to question 4. And this is a cos graph. And we've got part of the graph of the function y equals p cos qx plus r. And we need to write down the values of p, of q, and of r. Right, so p in this case is our amplitude. So that is the height from the center of the wave to the top. So the easiest way to do this is to look at how big a difference there is between the top of the wave and the bottom, and then half it. So to go from 4 to minus 2 is 6, and when we half that we get 3. So our amplitude is 3. Okay, so Q is how many waves there are in 360 degrees, or in this case, because we're in radians, it would be in 2 pi. So we have one cos wave in pi over 2, so that means there would be 4 waves in 2 pi, because 2 pi is, if we divide that by 4, we get pi over 2. And then our last thing is r, which is how much the graph has been shifted up or down. So considering we know our amplitude was meant to be 3, that means we know that the maximum value in this graph should be 3, but it is 4. So it's been moved up 1, so we've got r is 1. Right, okay, so we've got a function g is defined on the set of real numbers by g of x equals 6 minus 2x, and we need to determine an expression for g to the negative 1 of x, so that's the inverse of x. So we have g of x equals 6 minus 2x. So to do this, we let g of x equal y, and we're going to rearrange to get x equals, and that is our inverse. So we have y equals 6 minus 2x. So we add the 2x to the other side, so we have 2x plus y equals 6. We take away the y from both sides, so we get 2x equals 6 take away y. And then we divide both sides by 2, so we get x equals 6 minus y over 2. So therefore, g to the minus 1 of x is equal to 6 minus x over 2. Right, so for question part B of this question, we've been told to write down an expression for g of the g inverse of x, right? So g to the minus 1 of x. Okay, so the inverse of something and the opposite, or the normal version of something, they are the opposites of each other. So like adding is the opposite of subtracting, or it's the inverse of subtracting if you wanted to say it that way. So in this case, g to g to the minus 1 of x, they cancel each other out, leaving with us with it is just equal to x. And that works if we think about it in terms of like adding and subtracting. So if we start with a number, say 5, if we add 10, we get 15, and then we subtract 10 again, we get back to 5, which is where we started. And in this case, where we started is with the letter x in our function rather than a number. Okay, so on to question 6. Right, so for question 6 we are having to evaluate the logs. So we have log to the base 6 of 12 plus 1/3 log to the base 6 of 27. Right, so when we are, first things first, we can't have that third out the front, so we have log to the base 6 of 12 plus log to the base 6 of 27 to the power of a third. At this point, we think, well, 27 to the power of a third, what is that the same as? That is the same as just cube rooting something. Okay, so we think, well, do we know what the cube root of 27 is? So is there a number that we can times by itself 3 times to give us 27? And so it's not 2 times 2 times 2 because that would be 8, but 3 times 3 times 3 does give us 27. So we get plus log to the base 6 of 3. So once we've done that, we can combine using our log laws. We know if things are adding, we can multiply the bits in our log. So we get is equal to log to the base 6 of 36. So log to the base 6 of 36. 36 is the same as 6 squared. And then we can take the 2 down the front. So we get 2 log to the base 6 of 6. And anything to the base, if the base and the bit inside the log are the same, that's just 1. So our answer is 2. Okay, that does seem like I've taken quite a lot of steps there, and I have. Some of those steps, if you're happy enough to skip them, you would be able to. That's not a problem, but they're not going to penalise you for putting in every step of working. Okay, right, so on to question 7. Okay, so question 7, we have a function, and we have to find f dash of 4. So first things first, we're going to need to get it into differentiable form. So f of x equals the square root of x times 3x minus 2 over x root x. Right, so this is really checking in on, do you remember and can you do the stuff from National 5? So we've got x to the half, and then we have 3x minus 2 over x root x is x to the power of 3 over 2, because it's x to the power of 1 times x to the power of a half. And when we're multiplying things with powers, we add the numbers. So we multiply those two. So when we're multiplying, we add them. So we get 3x to the power of 3 over 2 minus x to the power of a half, or 2x to the power of a half over x to the power of 3 over 2. So again, remembering our index laws from National 5, if we've got, that's a half take away 3 over 2, so we're going to get 2x to the minus 1. Okay, right, so from there we can then start to differentiate. So f dash of x is equal to, so we multiply through by the power, so 3 times 3 over 2 gives us 9 over 2. And it's going to be x to the power of a half, because we take 1 away from the power. And then we multiply by our power, so we multiply by minus 1, giving us plus 2. And then we take 1 away from our power, so we get minus 2. And then we have to find f dash of 4. So f dash of 4 is equal to 9 over 2 times 4 to the power of a half plus 2 over 4 squared, because we can't really work out negative powers without changing them into positive ones by moving them from the top to the bottom. So we get 9 over 2 times 2 plus 2 over 16. So then we sort that out. So 9, so it would be 18 over 2 plus 1 over 8 when we simplify that. So we're going to get 9 and 1/8. So that's us for question 7. Now on to question 8. Right, so we have question 8. We have a rectangle with sides of length x centimetres and x minus 2 centimetres. And we've been told that the area is less than 15 centimetres squared. So determine the range of possible values for x. So area is length times breadth. So we have x bracket x minus 2 is less than 15. So when we go from there, what we're going to do is we're going to have x squared minus 2x minus 15 is less than 0. So to be able to do this, you need to kind of factorize so that we can sketch this graph, find its roots. So we've got x and x because that makes x squared. So we're looking for two numbers that multiply to give us 15 but add to give us minus 2. So 15, our options are 15 and 1, which doesn't work, or 5 and 3, which will. So we have 5 and we've got 3. So then we have, looking at this, we're going to have subtract 5 and plus 3. So if we kind of think about that graph there, just quickly, so we've got the point minus 3 and we have the point 5, and we're looking for where this is less than 0, or less than 15. It's less than 0 because that's what we've got there, but that would give us the less than 15. So between minus 3 and 5, however, if we look here, we have a side of our rectangle where x minus 2 is our side length. So x cannot be less than 2. So we know that therefore 2 is our minimum value of x, or x has to be slightly bigger than 2 at the very least. And our maximum value is got to be 5 because at that point it then becomes greater than 0, or so then that is our value, our range of values for x. So it's like this part of the graph here, that's 2, that gives us our values of x that will give us an area of less than 15. Okay, so question 9. Right, so for question 9, we have a, b, c are the points such that AB is parallel to the line with the equation y equals the square root of 3, y plus the square root of 3x equals 0, and BC makes an angle of 150 degrees with the positive direction of the x-axis. So are the points A, B, and C collinear? So when we're looking in 2 dimensions, collinearity is done by if the gradients are the same. So we're looking for MAB. That's what we're going to find first. So we have y plus, the square root of 3x equals 0. So we're going to have y equals negative root 3x. So therefore the gradient of AB is negative root 3. And then looking for B to C, we have, if we think about it, looking at it, our line B to C doesn't really matter right now, whereas this is just kind of to visualize. So it makes an angle of 150 degrees from the positive x-axis. So we also know that M is equal to tan theta. So in here with our cast diagram, so we have these here. It's in our second quadrant, so we know it's going to be negative, as tan is negative in our second quadrant, so not looking the worst so far, but we have tan of 150. So what is our equivalent acute angle? So in our second quadrant it's 180, take away A gives us our angle. So that means our angle is going to be 30 degrees. And this is one of our exact value triangles. So we draw this, and we have our 30 degrees up the top, we have 60 degrees down the bottom, and then we have 1, and we have 2, and we have the square root of 3, which you should know off by heart. So the tan of 150 is equal to the negative tan of 30. So the tan of 30 is, tan is opposite over adjacent, so it's 1 opposite 1, and then adjacent is root 3, so negative 1 over root 3. Okay, so our gradients are different, so therefore, as MAB does not equal MBC, they are not collinear. And that is us for question 9. Okay, right, so question 10. So we have that tan 2x equals 3 over 4, right? So the way I think of doing these is to create a triangle. So we have A in here, we've got 2x in there. So we have then tan is opposite over adjacent, so we have 3 and 4. And if we have 3 and 4 in our triangle, our hypotenuse has to be 5 because it's a Pythagorean triple. You might end up working this out through like Pythagoras, but you'll get 5, even if you don't remember that it's a 3, 4, 5 triangle. Right, so therefore cos 2x is equal to adjacent over hypotenuse even. So adjacent is 4 and hypotenuse is 5. So cos 2x is equal to 4/5. Okay, so then working out from there our cos x. So we know that cos 2x is equal to 2 cos squared x minus 1. So we're going to have 4/5 is equal to 2 cos squared x minus 1. So then we can add 1 to both sides. So 4/5 add 1 is 9/5. So 2 cos squared x is equal to 9/5. And then from there we can divide by 2. So we get 9 over 10 is equal to cos squared x. So cos x on its own is equal to plus or minus 3 over the square root of 10. However, because this is because x in this question has to be between 0 and pi over 4, we don't need that negative, so cos x is equal to 3 over the square root of 10. As this, because if it's between 0 and pi over 4, then it means that it is in our first quadrant, so it has to be positive, and that's us for question 10. Okay, so for question 11, we have t, the point -2, -5 lies on the circumference of the circle with equation x plus 8 all squared plus y plus 2 all squared equals 45. So we need to find the equation of the tangent to the circle passing through t. Right, so to find the equation of the tangent to the circle, first we need to find the equation of the radius to that point. So let's go. So we need to know what the centre of that circle is, and the centre of that circle is -8 minus 2. And then from there we can say the m from the centre to t is equal to y2 minus y1 over x2 minus x1, and we've got the point -2 minus 5 as well. So if we look at this, we are going to pick x1, y1 and x2, y2. So we're going to have -2 plus 5 divided by -8 plus 2. So that gives us 3 over -6. So if we simplify that, we get -1/2. So therefore, as m times m perpendicular equals -1. That means that m of t is true. So that's fine for that. So then you can therefore say we know the gradient or the equation of the tangent to that point is y minus b equals mx minus a. So we have y plus, so it's point t, so it's plus 5 is equal to 2x plus 2. So we have y plus 5 equals 2x plus 4. So we get y equals 2x minus 1. So that's us for part A. So then for part B, we have the tangent is also tangent to a parabola with equation y equals -2x squared plus px plus 1 minus p, where p is greater than 3, so we need to determine the value of p. Right, so from part A, we got y equals 2x minus 1. And so for part B, we need to let y equal y. So that gives us 2x minus 1 is equal to -2x squared plus px plus 1 minus p. So we need to set this equal to 0, and for it to be a tangent, that means that b squared minus 4ac equals 0. So I would write that down now. So b squared minus 4ac is equal to 0 for a tangent. Okay, so just in case you get stuck at any point, you've got that bit written down there, and you never know, that might be worth a mark at some point. So knowing that you've got to kind of set it equal to 0 because it's a tangent. Right, so we sort this out, so we're going to rearrange. So I'm going to move everything to make our 2x squared positive, so everything's coming to the left hand side of my equation. So we have 2x squared minus, plus 2x, and then move the px over, so minus px. And then we are going to take away 1, so that's going to make it take away 2, and we're going to add p, and that is all equal to 0. So then what we can do is we can kind of sort this out in a way that makes our a, our b, and our c more obvious. So we can take out, so we have 2 minus p all times by x. So that's taking out a common factor, but I've put the factor at the end of the bracket rather than at the start. But it's exactly the same thing. And then we've got plus p minus 2. So that again, kind of in a bracket to make it more obvious. So we have a equals 2, b equals 2 minus p, and c is equal to p minus 2. So then we can do b squared minus 4ac equals 0. So we're going to have then 2 minus p squared minus 4 times 2 times p minus 2 equals 0. So we multiply that out. So when we square a bracket, we square the first number, so we get 4. We times the two numbers inside the bracket together and double it. So that would give us minus 2p, so minus 4p. And then we square the last bit, so we get plus p squared. And then we've got 8 times our bracket, so it's going to be minus 8p minus 8 times 2, 16, and it's a minus times minus, so it's a plus, equals 0. So when we sort this all out, we get p squared minus 12p plus 20 equals 0. So we can factorize it. So we have p, and then we've got p equals 0. So things that multiply to give us 20, but add together to give us 12. So 20 could be 20 and 1. That doesn't give us 12 when we add them together. 10 and 2, that does give us 12. So we've got 10 and we have 2. And they are both going to be negative. So therefore, p is equal to 10. And this is because of a condition we have in our question, which is that p has to be greater than 3. So our two options would be p is 2 and p is 10, but obviously because we have that condition in the question, p has to be 10. Okay, so we've got a diagram shows part of the graph y equals a cos bx, and we've been told the shaded area is half a unit squared, so we need to find the value of that same integral between 0 and 3 pi over 4. Right, so I'm going to use colours and kind of write on it. So that's a half in there. What do we know about a cos graph? We know cos graphs are like symmetrical, so we know that this bit under here is kind of the same two of those bits above. So if we kind of split it, then we're going to have, there's a half there and there's a half there, like in here. Okay, so therefore we know that the integral between pi over 4 and 3 pi over 4 is equal to, of that function, of a cos bx dx is going to be equal to minus 1, because it's below the axis, so it means it's a negative area, or you get a negative answer when you integrate between those. So therefore, the integral between 0 and 3 pi over 4 of a cos bx dx is going to be equal to that first bit, which is a half, plus minus 1. So we get minus a half units squared. Okay, so on to question 13. Right, so on this question 13 we've got a function f of x equals 2 to the power of x plus 3 as defined on a set of real numbers. The graph with the equation y equals f of x passes through the point 1b and cuts the y-axis at q as shown in the diagram, and we've been asked for part A to find what the value of b is. Right, so if it was just f of x equals 2 to the x, then when x is 1, f of x would be 2. So we've got here, so we're actually finding f of 1. So it's 2 to the power of 1 plus 3. So that is 5, and that is equal to b. Okay, so for part B, they said copy the above diagram and sketch the graph with equation y equals f to the minus 1 of x, right? So I have this here, so I'm not going to sketch a different diagram. I'm just going to draw it on here. So if we're drawing the inverse of a function, which is what we've got there, what happens is we have the line y equals x, and we are reflecting our graph in that line. So it is symmetrical about that point, and we have something that looks roughly like that. So y equals f to the minus 1 of x. So that is part B1. Okay, which is 1 mark. And then for part B, part 2, we have to write down the equations, the coordinates of P and Q. So for here, we need to know what our reflected values are. So we know that we should have that this would be 4. So this means that on this point that is 4, which is Q, or Q dash because we've reflected it. So the image of Q has the coordinate 4, 0. And what happens with our image of P is that the coordinate goes and it flips, so the x becomes the y and the y becomes the x. So because we had 1, 5, that means we now have 5, 1. Right, so for part C, we have a point R, 3, 11, also lies on the graph with equation y equals f of x. So we've been asked to find the coordinate of the image of r on the graph with equation y equals 4 minus f x plus 1. Right, so we're starting with our coordinate 3, 11. And what's happening to it as we go through the transformations of this. So that plus 1 moves our graph to the left one. So that means that we're subtracting 1 from our x-coordinates, so we get to 11. So that's the x plus 1 part. And then the next bit is dealing with that negative f of x, so negative f of x part. That means we're flipping our graph, and it is in the y-axis, so our x-coordinates stay the same and our y-coordinate changes, so we get 2, and we're going to get negative 11, and then we're going to have to add 4, because we've got that last bit there. So we add 4, and that's to our y-coordinates, so we're going to have 2, and we are going to have minus 7. So therefore, r is equal to 2 minus 7. So it's just with that part C, step by step going through what do each of those things do, and kind of doing each of them to the coordinate as we go. So on to question 14. Okay, so for question 14, we have a circle with equation x squared plus y squared minus 12x minus 10y plus k equals 0 meets the coordinate axis at exactly 3 points. What is the value of k? Right, so first thing we need to do is find out a little bit more about the circle, so we need to find the center. So the center of the circle would be 6, 5. Right, so if we kind of just roughly sketch a circle like this. So if we know the center is at 6 and then 5 up, so we've got that there, 6 and 5. The only way to make this circle touch the axis at 3 points are for it to just meet the axis there, because that's further away, because it's 6 away, and then have 2 points where it crosses there. And I know this picture is horrendous, right? That's okay, because it's just a sketch. It's just for me to figure out what I'm doing. So that means our radius has to be 6. Okay, so from there, knowing that our radius has to be 6, then we've got r equals square root of g squared plus f squared minus c. So we're going to have 6 is equal to the square root of g is minus 6 squared, and f is minus 5 squared, and then it's going to be minus k. So we can square both sides, so we get 36 is equal to 36 plus 25 minus k. So the 36's cancel out, giving us k is equal to 25. So whilst that question kind of seemed like it was going to be really difficult, if we just kind of took a step back and we think about it and kind of sketch it and visualize it, it makes it that much easier. Okay, so on to question 15. Right, okay, so we've got the rate of change of temperature of a coffee mug is given by blah. Right, so T is elapsed time in minutes after the coffee is poured into the mug, K is a constant, and initially the temperature of the coffee is 100, not 0, definitely not 0, and 10 minutes later the temperature has fallen to 82 degrees. So it's asking us to express T in terms of, like big T in terms of little t. Right, so in terms of this, so our temperature, which is our big T, which is the equivalent of our Y, right, so initially, so at time 0, our temperature is 100. And we also have a second one saying that at time of 10, our temperature is 82. Right? So that's kind of what those bits have told us. And if we want to express t in terms of little t, we know that dt by dt is equal to 1 over 25 t minus k. Right, so then to get t, it is the integral of dt with respect to t. Okay, because we integrate to get back to what we started with. So we have t is going to be equal to, so when we integrate this, we raise the power and we divide by the new power, so it becomes 1 over 50 because it was 1 over 25, and then we've divided that by 2, so it becomes 1 over 50. And then our k is going to become minus kt. And then we're going to have plus c. Right, so now we need to work out our constant of integration and our t. So firstly, if we use 0, 100, we can substitute these in. So we know 100 is equal to 1 over 50 times 0 squared minus k times 0 plus c. So everything on the left hand side just stays the same. Everything on the right hand side becomes 0 apart from the c. So we know c is 100. And then using our other coordinate point that we got given, so we had 10 and 82, we know that 82 is equal to 1 over 50 times by 10 squared minus k times 10 plus 100. So we have 82 is equal to, this is going to be 100 divided by 50, which is 2, and then minus 10k plus 100. So then we add 10k to our left hand side, so we get 10k plus 82 is equal to 102. So we're going to get 10k is equal to 20, so k is equal to 2. So once we've got that, we can then write, therefore, t is equal to 1 over 50 t squared minus 2t plus 100. Right, so for that question it is a wee bit trickier, but it's just knowing to keep working through and to use everything the question is giving you, because they generally don't give you things for no reason. Okay? So that's the end of paper 1. So if you've found that helpful, could you please like the video or comment if there's anything you want to ask me about in the video. And if this has been helpful, please subscribe, it's really helpful, and let other people that you're sitting the higher exam with know, and that'd be really great for me if you could do that for me. So thank you very much for watching, and I really hope this has helped you, and good luck when your exam comes.